We're doing eccentric muscle training for strength, size, and speed. This is a paradigm shifter. This is going to change everything. And we're starting right now. I'm David Barr. If you're looking to get bigger, faster, stronger, get leaner, go longer, hit that subscribe and then the little bell so you don't miss the latest tips and tricks. And for this one, we are going way back. We're going back to a David Barr classic. This was shot nearly 10 years ago, and we're covering the basics of eccentric training. Not so much the basics. We are actually covering a more advanced version of it because right now you're using less than a third of your total force potential. And I'm going to show you why that is. Because if somebody told you, yeah, just train with a third of your strength, a third of your 1RM, you'd think that they're crazy. But that's exactly what we're doing. Not so much the RM, but we're training with a third of our maximal strength, even under that. So if we could tap into that, you can imagine the implications for muscle size, strength, and even contraction speed, which will ultimately translate into athletic performance. So there's two keys that we need to look at in this video. I'll show them from the old video using an isokinetic machine. This means that the device was moving at the same speed no matter how hard I was pushing at it. Okay, this is absolutely crazy. We haven't experienced anything like this before because we're typically used to pushing against gravity, right? Resisting against gravity. I mean, not just every rep we've ever done for the most part, but every step we've taken in our entire lives, we're always fighting gravity. We know what it feels like. So this is going to be very different when we start to change the types of resistance, moving into isokinetic. And this is not saying you have to move into isokinetic. This is just saying that this is the best example, the best way to illustrate what our maximum force potential is. So the first thing you want to look at is look at the strength curve on the bench press. And we're just talking concentric right now. I'm pressing up. It's a 2-second rep. So it's pretty long. 2 seconds doesn't seem like long, but it really is. And for this one, maximum force output is going to occur about mid-range, right? So this means that we have a strength curve for the range of motion. Throughout the range of motion, we exhibit different forces depending on where we are in the rep. This is because of muscular and biomechanical factors. We don't need to worry about the details. The point is we are not equally strong throughout the entire range of motion. This is very, very important. So look where our peak is and look where our base is and look at the magnitude of that difference. It's pretty huge, right? Now this is where we get kind of crazy. Once we move into the eccentric portion, this is where things blow up. Look at the size difference between the two reps, two portions of the rep, the concentric and the eccentric. And keep in mind, this is a relatively slow eccentric, so the force output's not going to be as high as it would be otherwise. And it is following concentric reps, so there was some fatigue going on, and this is probably like the 10th rep. So just a lot of time under tension has already occurred. A lot of fatigue has already occurred. So it's not an ideal situation, completely fatigue-free, but it's still pretty awesome. It's still very telling. So you look at the size of the peak, but you look at the start and the end, and it's identical to the concentric, right? The start and the end of the rep. These are going to be your areas of sticking point. Typically one's going to be lower than the other. Maybe it's coming off the chest in the bench press. Maybe it's lockout. It depends on the individual. But note that these are going to be your sticking points. So if you equate the maximum amount of force that you're putting out for the lowest portion of the rep, so on this, it's actually the minimum amount of force, right? The lowest part of the curve. What does that represent? And I talk about this in the original video because this blew my mind. It was one of the guys from the company who told me this, and I was just so blown away. That lowest point is going to be the maximum amount of load that we can train with if we're looking to complete a rep. So that's basically our 1RM. The lowest point on the curve is our 1RM. How crazy is that? So you look at how much force we're capable of producing, not just on the concentric, but the eccentric too. We are missing out on a huge force potential just in the concentric, right? Now, flip this over to the eccentric. Look how much force we are missing out on every single rep. And we're not even training with our 1RM, right? We're training with a percentage of that. So we're training with a lower level than the lowest point on that curve already, right? Otherwise, we could only do one rep and we'd be done. And if we train with more than that, we wouldn't be able to move the bar because we'd be stuck at our sticking point, right? We'd be stapled to the bench essentially. Now consider further that that force output is not actually the amount of load that we can handle. right? So say it's 200 pounds is our lowest point on those curves, 200 pounds. What would happen if we were to throw a 200-pound load on and start at our chest? Well, we wouldn't be able to move it, right? Because we're just equating the forces. It would be an isometric contraction. So we have to actually exert more than the load in order for it to move up, right? Now, conversely, to get it down, we have to exert less than the load. But the key point is we are not even training with the actual lowest level of force on that curve. We have to train with a lower level because that force level needs to be greater than what's on the bar. So again, if our force output is say 200 pounds, we have to train with, or even do a 1RM with like 195 pounds would be maybe the most we could do. And that's transient, right? We can't exert that for that long because it's a very heavy load for us. But in order to move that 195 pounds on the bar, including the bar, we have to be able to exert more than that. So that's where that 200 pounds comes in. And we can only do it once. It's our 1RM. So if we're training with 80%, say 80% 1RM sounds like a lot, right? Train with 80% of our 1RM. What's that load going to be? 80% of 195? But our lowest point on a curve is 200. So we're training with a much, much lighter load than we are capable of handling. And again, this has implications for muscle size, strength, and speed. And once we get into the eccentric component, it's exacerbated dramatically. I call it the bidirectional eccentric paradox, or the eccentric paradox for short. We'll get into that in different videos. This is actually the basis for book number 5. I'm just trying to figure out how to explain it to people. And I think that this video is really going to help. This is going to be a huge paradigm shift for us. I think it really will change the way we look at training, has implications for, like I said, strength, size, speed, and even potential to mitigate risk of injury. Now, I'm very precise with my wording there. You have to be, I mean, just because of the litigious nature of that claim. But it's one of those things that it could actually change the way we look at training forever. Because again, right now we're stuck on gravity. We're stuck on sets and reps. I mean, it's almost like sets and reps are a foreign language that only a few of us understand. So if you have like 5x5 at 80% 1RM, I mean, you write that out. That's a foreign language to most people, but you and I, we know exactly what that means, right? It's that ingrained in us. So if we can actually start to focus more on forces and the stimulus for adaptation, what we're actually after, and again, this is where the eccentric comes in. This is going to be such a massive stimulus for that adaptation, whether it's muscle growth, strength, speed, again, potential mitigation of injury risk. Heavy eccentrics is where it's going to be, and we can't always do it with a gravity-based load, and that's part of the problem. Is we've been trying to frame our eccentrics into these standard gravity-based loads, and it just hasn't really worked out as well as we might have thought. We also do it under fatigue conditions. I mean, this could go on. We will talk about this in different videos, but right now, look at the force differences and wrap your head around that. How much force output, how much strength we're missing out on every single rep. So take a look at the curves. Remember, this is isokinetic, so it's going to be moving at the same speed, the same rate of speed, no matter how hard I push on it. And that's 2-second concentric, 2-second eccentric. And the eccentric, we're actually stronger when we move faster eccentrically. It's not something we ever experienced. That is a whole other ballgame to try to wrap our head around. It's just very, very complicated, and it's counterintuitive, which is the biggest problem, I think, because we don't ever experience it. And if we do, it's for, short enough time that we don't really recognize what's happening. So, a lot to cover. That is eccentric muscle training for strength, size, and speed. Thanks for watching. If you like this video, check out other videos in this series. I'll link to them, and we'll have this as part of a playlist that will be linked. I think you'll really like it. We're going to have a paradigm shift, so you're on the bleeding edge of this. I know that's trite. I know a lot of people don't like it, but really that's our goal, is to not only advance the conversation, but help advance the field. So that's where we're going. Thanks for watching. I'm David Barr. Until next time, raise the bar.